talking about absolute value functions. The first of, I guess, the new material here in terms of ways that things will appear. We've been dealing with a lot of linear algebra lines that we would have seen in Algebra 1 class. We're going to start taking different shapes, I should say, and it starts off with absolute value functions. Now, before we get going with the absolute value function, we're going to see this phrase play itself out a couple different times, and it is known as the parent function. You can think about what the word parent means to everybody. Generally speaking, in mathematics, a parent function is the simplest function of a family that preserves the definition. So the starting point, if you will, all of the different absolute value functions that we'll look at while we go through this unit come from this location, and the formula, or at least the function for that, would be y is equal to the absolute value of x. So if I were looking at a graph like I have right there, this picture that we see is in fact an absolute value function. Now we can go ahead and evaluate this graph like we've always have. If x is equal to 2, what is y? These questions come down to just going to the location. There's x is equal to 2. Where does my graph hit? Of course, it hits at that point, 2, 2. Right, so we know that the y value would be equal to 2. If x is equal to -5, what's y? Now we know that the x is inside of the absolute value in our function, and we know how that effect plays out when we did this like in middle school, but I'll go over here to -5. There's the x value, -5, and where does our graph hit that specific location? That would be at the y value, +5. Doesn't necessarily surprise us. We take x value, we plug it into an absolute value function, and it comes out positive. That makes sense. We'll go ahead and take a look now at our different y values. So now I'm going to figure out these y values, and we'll go ahead with green. Y is equal to 3. This right here is where things start to pick up for us, and hopefully we'll see some patterns play out. But if I take a look at y is equal to 3, that hits in 2 locations, right there and right there. So what absolute value or what numbers go into the absolute value that produce 3? Well, if I take a 3 and plug it in, the absolute value of 3 is 3. Well, that makes sense. But the same thing occurs if I take the number -3. If I take -3, put it into the absolute value, it comes out as a +3. That makes sense to us. This last one, if y is equal to -4, what is the x? A little bit weird of a question. I'll go down to y is -4 on the graph, and we can see nothing in this picture, nothing in that absolute value function, which, by the way, kind of looks like the letter V, which is nice for value, but nothing hits there. So we don't have an answer for this. Okay, that situation here, that's not going to be an answer for us. It's not applicable in this situation. If you think about it, what number can you plug into an absolute value? When it comes out, would produce a negative number. There's no answer like that. That's impossible, given our parent function. So, for our parent function, of course, we're talking about that in this particular video. We should be able to, just like we have in the past, taking a look at domain and range. Domain covers all the x values. Now, I know I covered it up with a purple dot, but there's an arrow here, and that arrow is going left and up. There's an arrow here, and that arrow is pointing right and up. Domain covers the x values. Left and right is circled here with our arrows, so we know from previous examples that we're covering all of the possible x values, all the way from negative to positive infinity. What about the range? Well, it's impossible in this situation, in the parent function, to get any y value that's negative. So we should hopefully see that our bottom location here is right there. In fact, there's a special name for that we'll go over And this right here, that location where we're changing directions, that's known as the vertex, which we'll talk about a lot going forward. But we know that there's no point below that location, and if I'm looking at range, I'm talking about y values. I only have the word up. The lowest location is 0. So it is 0 is less than or equal to, because that dot, that vertex counts. It's a very big deal, in fact. And of course, since the arrows are traveling up, we're going to positive infinity. So that's a conversation about the parent function. Everything we do in this unit is going to be based off of that and how we will be able to move the different absolute values from that location.